To continue our discussion about data structures, let's take a look at queue. So a queue is a data structure that is based on first in, first out strategy. It has many applications where queuing is required, such as message queuing. So in networking, you will see that a node is going to receive messages and then it's supposed to send forward it to the next nodes, and the order in which the messages arrive, that's the same order in which the message is supposed to leave the node. So that means the message that comes in first is supposed to leave first. So that is the first in, first out. One of the applications where first in, first out or a queue is used. So let me explain what a queue looks like. Queue is a data structure that we have available in many programming languages. It is not specific to any programming language. What it basically means is we can have like a container in which we can add some data, and when we add data to the container, the term is enqueue. So let's say we added A into this into the queue, so that's the first element that's gone in. And then let's say we added B, and then we added C, right? So we've added A, B, and C. In a queue, it's the first element that got in that is going to come out first. So when you try to remove something from the queue, it will fetch out the thing that was added in first, and the term used is dequeue. So when you enqueue into a queue, that means you've added something, and when you dequeue, it means you've removed something. And the way that the arrangement of going in and out is called FIFO or FIFO. So first in, first out. Okay, so that is what a queue is. We have some easy ways to implement a queue in Java. It's not difficult at all. You can simply use the linked list as a queue, and I will discuss that on paper. In Java, you have a simple way of implementing a queue, right? Because we have a linked list class that's already there in Java. So all we need to do is create a so I'm just writing the code here, right? So queue, and then you have to use the wrapper class integer. I'll explain that in a little while. And the name of my queue, I'll just call it queue. Okay, so this is equal to a new linked list class instance, right? So linked list, and it's the wrapper class integer. And this is how you create a new queue in Java. You have to use the and you have to create an instance of the linked list class, and the data type is going to be inside your queue. So your ABCs, these are going to be integers. So this is the wrapper class integer, not this int, right? So you're not using this int. This is how we create the queue. But now how do we add things to it? We can simply say queue, the name of the queue, queue dot add. So using the add method, we can add things inside this queue. So let's say I've said I want to add integers into this queue, so I can just add 1, right? So this adds an element inside my queue. Let's say I want to add another element. Let's say I add 2, right? So these are elements to these are methods to add, or the queue term for that, like the technical term for queuing is enqueue, but in Java we don't have specific term for that. It's just add, right? So this is when you are adding, you are actually doing enqueue. And when you are dequeuing, or if you want to remove something, by the way, what has happened here so far, let me draw out what has happened. We have in this line, we have created a queue. It is called queue. Okay, so this is what's happening. You have a queue, and then on this line, what are we doing? We have added a number, an integer to it, which is 1. So we have an element in there. 1. Okay, and then this line of code adds another element in there, 2. Okay, so at the moment this is what's happening based on the 3 lines of code that we have. Okay, so first, if I wanted to remove something from this queue, what do you think will be removed? The thing that got in first, right? Which is this 1 will be removed first. So how do I remove, or how do I dequeue using a Java code? I have a method available to me called remove. So I simply do queue.remove, and I don't pass anything because it is just going to remove the last thing, or the first thing that was added into the queue, which is this 1. And this method actually returns the thing that is removed. So I'll just show you a bit of code that will make more sense. Also, removing means dequeue, right? So that's basically what's happening. Of course, Java does not have a method called dequeue. The method is just remove, and the method for unqueuing into a queue is just add. Okay, so in this line, what will happen? This 1 will be removed. It will be taken out of this queue. So no more this element here. If at this point, if I try to print the queue, what will be printed out? Just this 2, which is in it, unless I added some more things to it. Okay, so I hope that makes sense of what a queue is, especially in Java. Let me show you some code and implementation of queue in Java. So here I have to import the library for linked list and also the library for queue, right? So you have to import these two, and then in your main method, well, in my main method, I have added in this code for a queue. So how do I create the queue? Using this code, right? So a queue with the wrapper class integer. So my queue is going to hold integers in it, and I use the linked list class. Right now, in this part, I am going to fill my queue with 5 elements, 5 integers, and the integers are going to be from 0 to 4. So 0, 1, 2, 3, 4. Those are the things that I'm going to fill into my queue. And what will be the first thing that goes in? So it's going to go in as starting from 0. When int I is 0, I'm going to add that 0 into the queue, right, using the add method. So at this point, my queue contains 0. Then next iteration of the for loop, my I will become 1. So I'm going to add 1 to my queue. So the next element in my queue is 1. So at that point, I've got 2 elements in my queue, 0 and 1. Then next iteration of the for loop, my I becomes 2. So 2 gets added into the queue over here. So at that point, my queue contains 3 elements, 0, 1, and 2. And the next iteration, I becomes 3. 3 gets added. Next iteration, I becomes 4. 4 gets added. Next iteration, I becomes 5, but 5 is not less than 5, so we exit the for loop, and we would come to this line where we are going to print elements of queue, and then I'm going to print whatever the elements of queue are. Okay, so that's what's happening here. It's going to print all the elements of queue, and what do we expect? We expect it to print out 0, 1, 2, 3, 4. Then I'm going to create an element called a variable called removed element, right? So it's going to be an integer. So I want to hold the removed element in here, and I can remove an element from the queue by using the remove method, right? So which element do you think is going to be removed from the 0, 1, 2, 3, 4? Which one do you think? Because it's a queue, it's going to be first in, first out. So the thing that was added in first was 0. So we expect at this point that 0 will be removed, and 0 will be stored in this variable called removed element. Okay, then I'm going to, in this line, print out the removed element, right? So removed element, and then print out whatever is in that variable, and we expect that to be the 0, which was inserted first. Then I'm going to print out my queue, and what do we expect to be in the queue at this point? We expect 1, 2, 3, 4 to be in the queue. 1 Why not 0? Because 0 has been removed over here. Okay, then we have another variable being created. It's called head, and it's going to be an integer. So in this variable called head, I'm going to store something that I am fetching using this method called peek. So a queue allows me to take a peek, right? So what this method does is, instead of removing, it's just going to take a peek at what is the thing that's going to, that's going to be removed, or that's at the head, right? The first thing that is in there at the moment. And what is there at the moment? We have the elements 1, 2, 3, 4. And the first thing in there is 1, right? So we expect 1 to be checked, not removed, because it's peek, it's not dot remove, right? Peek is only going to take a look at what there is, and what is there is 1. So 1 will be stored here in this variable, and in this line I am printing out head of the queue, and the head is supposed to be holding 1 at the moment. Then I'm printing the whole queue, and what is the whole queue? It's still 1, 2, 3, 4, because I have not removed anything from there. I just took a peek. Okay, then we have this variable called size. It's holding an integer, and this, by the name of the method, it's probably going to return the size of the queue for us. And we know that the size is 4. We have the elements in there 1, 2, 3, 4. So we expect 4 to be returned and 4 to be stored in this variable called size. And so here, when we print it out, we expect the size 4 to be printed out. And then finally, we're going to print our queue again just to have a look what is in there. And what do we expect to be in there? 1, 2, 3, 4. Okay, so I will run this, and let's see. Okay, so what did we get? Firstly, we had the elements of the queue 0, 1, 2, 3, 4. Where did this happen? Over here, right? In the for loop, we added the elements, and then on this line, we printed out the queue, which is here in the output. Then we removed element 0. We removed the last element, right? And that was stored in the variable called removed element, and we printed out removed element. So it printed out the 0. Then we printed out the whole queue, which is printed out here. So 1, 2, 3, 4 is what remains in the queue. Then we have peek, and with peek we get to see what is the first thing in there, which is 1, right? And we printed that out here. Then we printed the whole queue again, which is 1, 2, 3, 4. Then we got the size, and we printed the size, and the size of the queue is 4. And then we printed the whole queue again, which is holding 1, 2, 3, 4. Okay, so I hope that explains how to implement a queue in Java. Another data structure is a stack. The stack data structure is based on last in, first out strategy, so LIFO. Stacks have many applications, from parsing of algebraic expressions to keep track of variables and return address values for function calls. So you did something about that in CS214. So a stack works the other way. You will have a container and you add your elements to it, and the term we usually use for that is called push. So you push an element in. Let's say you added A, you added B, you added C, but when you remove something from it, it will be the last in that comes out first. So C will come out first, and the term the abbreviation for that is LIFO or LIFO, which means last in, first out. So the thing that got in last, which was C is the first that will come out, and the term usually associated with this is POP. Okay, so generally this is the idea behind queue and stack. Okay, let's try to implement a stack data structure in Java. So first of all, I need to import the java.util.stack library in there, and then in my main I'm going to implement the stack. So to create the stack, I have to use the, if I want to fill my stack with integers, I have to use the wrapper class for integer. Right, and let's call this stack SDK, or let's call it my stack. So my stack is going to be a new stack. Right, so at that point, a new stack will be created called my stack. Now let's try to add something to my stack. As I mentioned, the keyword for stacks is push if you want to insert things into your stack. So my stack dot push, and I have said that I will fill the stack with integers. So let's say I just want to add the number 5. Right, now let's just try to print the stack and see if the 5 has been added to the stack. So system dot out dot print line my stack. Save F6. Okay, so here is my stack being printed, which now contains 5. Let's try to add some more things to this. So I add 23, 58, -15. Okay, now let's run. Right, so this is what our stack contains now. How do we get things out of this stack? We know that the stack follows not first in, first out, but last in, first out, right? So last in, first out, what has been added last to the stack? -15. So when we pop something out of the stack, we expect the last thing that was added, which is -15, to be popped out first. So when we pop something out, we will be returned the element and we will want to store it somewhere, right? So let's say an int popped equals my stack dot pop, and then we try to print out the thing that was popped. Right, so what I'm trying to do now is, after popping something out of the stack, which we actually expect is going to be the last thing, which is -15, we expect the -15 to be stored in here. Then I want to print out and just check if that really is -15. That's what will happen in this line. And then on this line, I want to check what is remaining in my stack. Okay, so let's run this. Right, so when we print out what was popped, it was the -15, and then we print out this stack, it no longer contains the -15. Okay, so that is how we implement a stack in Java. So on this slide, when the slide was made, there wasn't a good implementation of a stack in Java. So you were asked to create your own stack. You can give it a go in your own time and maybe post it in the you can post your solution in the discussion forum for others to see. A special type of queue is a priority queue, and a priority queue is an extension of the queue which has the following properties. Every item in a priority queue has a priority associated with it. So an element with a high priority is dequeued before an element with low priority. So applications for this include things like load balancing in operating systems, Dijkstra's algorithm, which we will discuss later in the course, and processing job requests based on priority. So This is just a normal queue that we discussed, but every element has a certain priority, and things with higher priority get processed first, or they will be removed first. Implementing priority queues in Java is pretty easy. However, there's an additional step that you need to consider. You can use the java.util.priorityQueue. It provides the basic operations of priority queue. So you would say, okay, priority queue, let's say you want to fill your queue with strings, so you say string. If you are filling your queue with integers, you would put in the wrapper class for integers with a capital I. Anyway, and then here you are calling it queue equals new priority queue string, and then size and comparator. Okay, so this comparator is a bit tricky. This is the new thing that you have to learn. The comparator needs to be a user-defined comparator, and you need some understanding of inheritance in order to implement this. Let me show you sample code. I will also provide link to that code in our Moodle week 1 section, so you can try to implement it. It will take a while to understand. Here is an example of a customer order, right? So let's say you want to create objects that are customer orders, and each customer order is going to have an order ID, an order amount, and a customer name. Okay, so every customer order is going to have ID, amount, and name. Okay, and here this is the constructor which fills in the order ID, amount, and customer name as you create a new customer order object. And here we have this is how we override the comparator. So here, taking the customer orders IDs will be compared and then arranged in descending order. So you can play around with that. Here, let's say you create 3 customers, customer order C1, C2, and C3. C1 is a new customer order. You're giving the ID as 1, amount $100, and the name is customer 1. C2 is a customer order, and the ID is 3, $50, customer 3. C3 is a customer order. You have passed ID 2, and the amount is $300, and the name is customer 2. So let's say you have created 3 customers, and then you have a queue. Your queue is called customer orders, and it's a priority queue. So you want to organize the elements of your customer orders queue in some particular way. Okay, so after creating the queue called customer orders, you want to add in your customer orders queue, you add your C1, which is the first customer order that you created. Then you add C2, which is the second customer order you created. And then you add C3, which is the third customer order you created. Recall that we had overridden the comparator to make sure that the queue gets arranged in order of the order ID in descending order, right? So the highest order ID should be in the queue first, and the lowest order ID should be in the queue last. So when we print out our queue, let's see what we get. The first order ID going in was 1, then the next order ID was 3, then the next order ID was 2, but then it got arranged due to the priority, and the priority is to put highest order first, right? And the highest order ID is 3, then the order ID is 2, then the order ID is 1. So we expect it to be now as 3, then 2, then 1, which is customer 3, then customer 2, then customer 1. So when we do print it out, we get customer 3 with order ID 3, customer 2 with order ID 2, and customer 1 with order ID 1. If we change our comparator, if instead we want to compare by the amount, right? So we just change the comparator and say, okay, compare the order amounts. and arrange it in descending order. Okay, so now we can then if we print it out, we will see that the order amount is the thing that determines the priority. So $300, and then which was customer 2, then $100, which is customer 1, $50, which is customer 3. Okay, so I will post a link to this, and you please do try it out and make sure you understand. Another popular data structure is the binary tree. So in Java, we can also implement binary trees. Okay, so I will ask you to create your own binary tree after I explain what it is. You also have a heap data structure. So you have a binary heap that is a complete binary tree where all levels are completely filled except possibly the last level. The value of each node is greater or less than or equal to the value of its parent. Okay, so in this area, I will ask you to do a bit of Googling so you can learn on your own about binary trees. Let me explain what it means. This is an example of a binary tree, right? So you have one node. This is the root node. It will have children nodes, or it's the parent node, and you have branches. And the last nodes here, these are the leaves, right? So, or these are children with no other children, right? So this is the root, and it branches down into other nodes, and each node can have other nodes, and each node points to other nodes, and so on. So if we implement this in programming, what we will need to do is create a node class where each node class can have a key, which is the value it's holding, and it can have a left branch and a right one, right? And then that points to another node. And so you create another instance of a node, which is pointing to another node and another node, and so on. Okay, so this is basically what a tree looks like. It can have a binary tree, means it has two, it's pointing to two other nodes and not more. Otherwise, a tree can have multiple nodes, not necessarily only two. When it's pointing to only two, that means it's binary tree. So a very useful thing that we have when we deal with data structures is that most programming languages and platforms provide built-in algorithms for these common data structures like trees and queues and stacks, as we have mentioned, right? So in Java, you can use the collections package, which provides many useful and easy to use methods like sort. So you can simply have an array, or you can have a queue, and then you can sort. Oh, sorry, not sort in a queue, but you can have an array and easily sort, or you can find the minimum just by using this method, or you can find the maximum, or you can implement a binary tree, which would be represented as an array actually, and then just call the binary search method, and that will find something for you. Or you can do arrays dot sort and arrays as list, right? So you have many methods that are easily ready to use. Okay, that ends our discussion about data structures.